Electricity is produced in alternators by electromagnetic induction. To generate electricity in a coil, either the coil should rotate with respect to magnetic field, or a magnetic field should rotate with respect to the coil. In the case of alternator, the latter approach is used. Rotor and armature coils are the two main parts of an alternator. Rotor produces a rotating magnetic flux. Armature coils are stationary.
If you're driving down the interstate at 2,000 RPM, this could be spinning anywhere from 4,000 to 6,000 times a minute. If these were constantly energized, it would overcharge your battery and burn your system up. If you're stopped at a traffic light, your car is idling at 700 RPM, this is going at about 2,000 RPM. You turn your lights on, flip your high-powered stereo system on, flip the blower on for your air conditioner. The electrical system gets a tremendous load. Put your windows down, lock your power lock doors, all of that causes the electrical system a higher amp load, so the alternator increases the magnetic field at the same
Flame. As combustion occurs in each cylinder, energy transmits to the engine crankshaft, which generates mechanical power for the alternator. An alternator converts mechanical power into electrical energy in a process called magnetic induction. Magnetic induction occurs when a conductive material such as a copper wire passes through a magnetic field and voltage is produced. If the wire is connected in a complete circuit, the power can be transmitted. Alternators include two primary parts, a stator and a rotor. The stator contains copper coils wound into the alternator's outer casing. The rotor also has wire coils wrapped around an iron core, but unlike the stator, it is attached to the engine crankshaft so it rotates with the engine. When voltage passes through the rotor coils, it creates an electromagnetic field. As the rotor spins, its magnetic field cuts across the stator's conductive wire and generates voltage. Because the magnetic field builds and subsides, voltage fluctuates between positive and negative peaks, which is known as alternating current. The stronger the field, the higher the peaks. Ideally, voltage levels should be consistent so that constant power is provided when under load. To do so, an automatic voltage regulator, or AVR, adjusts the magnetic fields as needed. During heavy power demands, voltage decreases, causing the AVR to increase the magnetic field. Conversely, when power demands are low, the AVR tempers the field. Doosan mobile generators also include alternators with 6 coils wound into the stator. This provides 3 voltage sources or phases. Because each phase combines 2 coils of wire, the sources can be connected in series for high voltage applications or in parallel for low voltage needs.